So let's look at this topic, binomial theorem. This is one of the interesting topics in the senior high school elective mathematics. Some students have a lot of challenges when it comes to this topic. So we are going to see how we can help some of our students to clear their mind. So for today's lesson, we are going to look at how we can expand binomials, how we can expand it, how we can expand binomials using what we call Pascal's triangle. Good. So Blaise Pascal is a French mathematician, and she developed a triangular array of numbers to help expand binomials. Yes, so we are going to look at how we can get those array of numbers in a triangular form so that we can use it to expand binomials. So whenever you are given a binomial to expand, we can use what Pascal's triangle. Though in this topic, it is not only Pascal's triangle that can be used to expand binomials. We have other topics, but for the purpose of today's lesson, we are going to focus or center our lesson on Pascal's triangle. So let's say you have been given this. Let's say you have x plus y exponent 2. If you are asked to expand this, I know for this one it's very simple for some of you, so you can do it easily. But what if you have been given this? If you have been given this x plus y exponent 6, what if you have been given this? You see, when you have been given, whenever the power is large, a little bit bigger, it becomes so difficult to expand. And for that matter, we have to introduce what Pascal's triangle. So with Pascal's triangle, we'll be able to expand this with exponent 6 without even wasting my time. So let's see how we can use Pascal's triangle. So let's begin with, let's say you have a plus b exponent 0. So we start with exponent 0. So you know that any non-zero number exponent 0 gives us what? I know you can tell me the answer. Yes. So it gives me 1. Good. So if I'm getting 1 here, that 1 I'm getting, that is the coefficient. So actually, Pascal's triangle helps us to get the coefficient whenever we expand binomials. Because if I ask you to expand this, you are going to get coefficient. But what will be the coefficient? So the coefficient, because it is 0 here, then we are getting 1 as our coefficient. So that is the first coefficient for this. If we should expand it, that's what we are going to get. Okay, now let's continue with a plus b to the power of 2. Good. Or let me start with 1. Yes, let me start with 1. Good. So to the power 1. So a plus b to the power 1. What do you think will be the coefficient? Now you know that any number to the power 1 gives me the same number. I know yeah, the same number. Good. So if you can bear me out that any number to the power 1 is the same number, then it means that here we are going to still get a plus b, but we are not interested in the variables. We are interested with the coefficient, because for binomials it deals with coefficients. If you don't know the coefficients, then the whole work becomes something else. So what is the coefficient of this? So we know that the coefficient of the first term is 1. So I'll write my 1 here. What is the coefficient of the second term? It is Also 1. Have you gotten that? Good. So we are saying it is binomial because it has how many terms? Only two terms. So the first term and the second term. That is what binomials. Now, as we are moving along, you see that the extreme ends, the first extreme end and the last extreme end always what? 1. And according to Pascal's, he says that whenever you are generating a triangle, the first what coefficient should be 1 and the last coefficient should also be what? 1. And it is clear, you can see that the coefficient here is 1. What is here is also 1. So let's continue. Now let's say we have a plus b exponent 2. Good. So our coefficient, the first coefficient is 1. As usual, that's why I say as we are moving on, the coefficient of the first and the last extreme digits will be 1. So the first one is 1. But how do we get the middle numbers? So according to Pascal's, he says that to get the middle number, we need to what? Add the previous coefficient above that number. Have you gotten that? So to get what is here in the middle, I must add what? The previous what? Coefficient, which is above it. So this plus this will give me what? 2. So I'll put my 2 here. And then the last coefficient will give me what? 1. Have you gotten that? Good. Now let's move on. So we have a plus b to the power of what? 3. Good. So as usual, what will be the first coefficient? So the first coefficient will give me 3 and 1. Sorry. So 1 here. How do I get what is here? So the previous what digit, that's the previous coefficient. We have 1 here, we have 2 here. So it is above the number I'm going to write here. So I'll add this to this and I'll get my 3 and I'll write it here. So what should I write here? I look at those 2 digits above it. Then if I add it, I'm getting what? 3 here. And then the last coefficient will give me what? 1. Have you gotten that? Now let me add another one. We have a plus b exponent 3. Good. So here is already 3. So let's make this 4. So we have 4 here. Good. So my first coefficient gives me what? 1. And what is above here? 1 and 3 is above here. So I'll add this to this. And I'm getting what? My 4. What is above here? 3 and 3. So I'll add it and I'll get my 6. What is above here? 3 and 1. So I'll add and get my 4. Good. And then the last coefficient is what? 1. So I will write my 1 here. Then let me add the last one, which is a plus b exponent 5. So what is the first coefficient? Is 1. So I will add this to this. I'm getting what? 5. This to this, I'm getting what? 10. This to this, 10. This to this, 5. And then the last one is what? 1. So looking at it, you could see that it follows what? A pattern. It follows a pattern. So Pascal's triangle, it is what? A triangular what? Array of numbers that follows what? A specific pattern. So looking at it, you see that it is following a pattern. Isn't it interesting? Yeah, very interesting. So if you look at it, you see that it is forming a triangle. Have you gotten that? So we are forming a triangle here. That's why we are saying that this is what? A triangular array of numbers. Have you gotten that? So the numbers are forming a triangle. That's why we call it what? Triangular array of numbers. Good. So all these numbers you see here, they are the coefficient of this. When we expand this, they are the coefficient of what? These binomials. Good. Now let's see how we can get the expansion from this coefficient. So the first one, which is 1, you know that it is 1. So normally it should be what? 1. So my 1 must come. But how do I get the expansion for this? And because we are saying this is a, so a times the coefficient, I will get my what? My a. B times my coefficient, I will get what? My b. Have you gotten that? Good. Now let's move on to the next one. So this is a. A times the coefficient will give me what? A. But when you get here, because the exponent is what? 2. So I will add my exponent here, then plus, what is the next coefficient? It is what? 2. But I've written 2 here, and as we move along, the exponent of the A will reduce by 1. And as soon as the A starts what? Reducing, then the B also what? Starts. We are talking about the exponent. So here it is 2. So when it is reduced by 1, it is left with what? Exponent 1. That's why I didn't write the 1. So the B also starts, and the B starts what? Increasing. So that is the nature of this what? Pascal's triangle and the expansion. Good. So let's continue. Plus, what's my next coefficient? So my next coefficient is what? 1. And B times this will give me what? B. But we are saying B is also increasing. So if from 1, then here will be 2. Have you gotten that? So we are done with the 2, the exponent 2. So let's move on to the exponent 3. So for this one, we are saying that the first coefficient is 1. So 1 times A will give me what? My A. But what is the exponent? The exponent is 3. So as soon as the 3 is here, when I move on to the next term, the 3 will be reduced. But what is the coefficient? So the coefficient is 3. Have you gotten that? Good. So we are saying A should be reduced by what? 1. So I'll write my 2 here. Then the B also what? Starts. Have you gotten it? Good. So my next coefficient is what? 3. And then the A will reduce by 1. Then the B will increase by what? 1. Have you gotten that? And then what is the last coefficient? So the last coefficient is what? Plus. So 1 times B will give me what? B. But B will increase by 1. So we have exponent 3 here. Now let's move on to the next one, which is what? Exponent what? 4. I know you are following the pattern. You see the way it is going. Good. So we have here as what? So the next coefficient is 1. So 1 times A gives me what? A. But what is the exponent? The exponent is what? 4. So I'll write my 4 here. Plus, what is the next coefficient, which is 4? And then A will reduce by 1. So I have 3, and then B starts. My next coefficient is what? 6. A will reduce by 1, and then B will increase by what? 1. My next coefficient is what? 4. And then A reduces, B what? Increases. Then my last coefficient is what? 1, which is B. So my B is exponent 4. Great. Now I know you can do the fifth one. Very, very simple. So in fact, Pascal's has helped a lot because majority of students find it so difficult. But once they understand this triangle, then it's very simple. So let's add the fifth one. So what is the next coefficient? So we have 1. 1 times A gives me A. But what is the exponent? It's 5. Then my next what? Coefficient is 5. So I have 5 here. I have A to 4 because it is reducing. Then B. My next coefficient is what? 10. Then A exponent 3. And then B exponent what? 2. And then my next one is 10 exponent what? So A exponent 2 and then B exponent 3. My next one is what? 5. So 5 A exponent 1, but we'll not write the 1. Then B exponent 4. So my last term, which is 1 times B, will give me B. But what is the exponent? 5. Good. So all this you will see here. So this is the expansion of these binomials. So when you are asked to expand this is what you are going to get. So this is the expansion, whilst these are what? The coefficients. Isn't it interesting? Very, very interesting. So great. Now this is what? Pascal's triangle. So once we have been able to use Pascal's triangle to get the expansion, then whenever you are given similar examples to use or to expand, you can use Pascal's triangle. Now, in our next video, we are going to take examples and then you look at how we can use Pascal's triangle to expand those binomials. So, see you next time. Thank you.